So here's another problem that people asked about was number 1215. How long will it take the capacitor to discharge to 25 volts when the switch is closed? So it's got 100 volts on it, and you close the switch, and now it's going to discharge. Well, first thing is, what's the time constant? Okay, so the time constant, your capacitor is 1 microfarad. Your resistor is 2.2 kiloohms. So your time constant is RC, and that's going to be 2.2 times 10 to the third times 1 times 10 to negative 6. So obviously we have 2.2 times 1 is 2.2, 10 to the negative third, 10 to the negative 6 is 10 to the negative 3, and so that's 2.2 milliseconds is my time constant. So now I'm going to go back over to my charging graphs. Let's see, I use this clean one. And we're going to back to 50%. So over here, it starts off at 100. You want to go down, sorry, 25%. We go to 25 volts. So you're discharging, you start here, and it's going to go down. That's going to be 0.25 of the original. So 0.25, come over 0.25 to here. Oh, and look, we're back at about the same thing. That's about 1.2, 1.4 time constants. So a time constant, though, is 2.2 milliseconds, so I have 1.4 times 2.2, and that equals, got my calculator, da-da-dum, calculator, 1.4 times 2.2, 3 milliseconds. So that comes to 3.08 milliseconds. Is that the answer the book's got? Yeah, 3.05. Oops, sorry. 3.05 milliseconds. I got 3.08 milliseconds. They use log functions. That's okay. If you like log functions, you can do log functions. But in general, I think that understanding these curves is as important as understanding log functions. If you understand these curves, then you're in good shape. And if you like these, if you like the log functions, and you had that algebra, good for you. But this is as crucial as this is.